Hi everyone, I'm Sophie from Carnegie Mellon University. I'm presenting our paper, Detecting Interpersonal Conflict in Issues and Code Review, Cross-Pollinating Open and Closed Source Approaches. As a social technical activity, software development involves communication that are not always healthy. One study found that free and liberal open source software communities are such a rich source of insulting or profane speech data. Negative communication experience can be discouraging, especially to marginalized groups such as women and newcomers. Automatic detection can help with prevention and mitigation. For example, Stack Overflow uses a bot to flag unwelcoming comments, and there are some tools by Google and other research groups. But off-the-shelf tools don't always work well in software engineering. Some of the reasons include technical jargon, word contractions, emoticons, URLs, and code snippets. One example is that in real life, kill and execute might mean something similar, but it is not the case in software engineering. Therefore, kill the process is an ordinary command and is not coming from Queen of Hearts. There are several tools developed independently in software engineering, for example, sentiment analysis, anger detector, toxicity detector, and pushback detector. Our work expands on the paper by Raman and colleagues and the one by Eggleman and colleagues. We chose these two works because they were the most recent when we started this study, and they're different along several axes. One is across contexts. Raman's paper works in the context of open source, whereas Eggleman's paper situates in a corporate setting. Also across types of communication, Raman's work focuses on issue discussions, whereas Eggleman's work focuses on code review. Also across concepts, Raman's paper centers around the concept of toxicity, which is defined as a rude, disrespectful, or unreasonable comment. Whereas Eggleman's paper uses the concept of pushback, which is defined as the perception of unnecessary interpersonal conflict in a code review, while a reviewer is blocking a change request. Also across methods, Raman's paper uses text-based features to build a classifier, whereas Eggleman's paper uses logs-based features to build a classifier. We have several research questions. For example, can we cross-apply the methods? How much can a toxicity detector classify pushback? Can these tools work across contexts? And finally, can we combine them? The short answer is yes to some of them, and for more details and the rest of research questions, please read our paper. We encountered several challenges along the way. For example, we need to construct new datasets to bridge the two prior works. We also need to refine the features. For example, we can't replicate all features from Google, and we have to use approximations. Now I'm going to present some result highlights. We retrained the text-based classifier for issues on code reviews. We see a lower performance, although both are quite good. We have some speculations, and please read our paper to find out. We applied them across contexts. We retrained the log-based classifier for corporate code review on open source code review. Again, we see a lower performance. It might be because we can't replicate all features and we need to use approximations. When applying across methods, we apply both the text and log-based classifier on toxicity. The result shows that a text-based classifier performs better when detecting toxicity, suggesting that toxicity is mainly about the use of inappropriate language. We apply both the text and the log-based classifiers to detect pushback in corporate code review. We found that a text-based classifier works better. This implies that although pushback was initially defined as a delay in code review, there's more nuance in the language. There are still many open questions, such as how to improve the classifiers, how to expand the datasets, which are now quite small, and how can we perform prevention. In summary, in this work, we cross-pollinated the two prior works across several axes. We overcame several challenges along the way, including datasets and features. I highlighted some results here, and please read the paper for more. The results have many implications on future research directions and open questions. To learn more about this study, please scan the QR code for the full presentation and read our paper. Thank you.